Okay, now we will go through the questions on chapter 12 in project number 1. The first one is on drinking habits. It says here in a nationwide survey, 1,000 American adults were asked whether they drink alcoholic beverages at least once a week. So, as you can see, this question is a yes-no question. And the special attribute that we are looking for is whether somebody drinks alcoholic beverage at least once a week or not. Okay, and whoever or however many said yes will meet our special attribute and will be considered a success, from which we will be calculating our sample proportion. So let's read on. It says 38% said yes. Determine and interpret a 95% confidence interval for the proportion P of all American adults who drink alcoholic beverages at least once a week. Okay, so the first step is to determine the sample proportion denoted by P hat. That's sample. All right, whenever we put the hat on the P, it becomes the sample proportion. If you do not put the hat over P, that means you're referring to the population proportion. So P hat is 0.38. How did we find that out? From this 38%. They have given it to us in the question as a percentage, but proportion has to be a decimal value between 0 and 1. Therefore, convert the percentage to proportion. All right, and so that's the success proportion, 0.38, and 1 minus P hat represents the failure proportion, right? Those who did not meet the particular attribute. So that will represent the failure proportion. And this one is the success proportion. Now in the next step, it says, decide whether using the one proportion Z interval is appropriate. Explain why. So you have to recall the assumptions in order to find or use the Z interval procedure. Of course, it has to be always a simple random sample, but it also has to meet this criteria that x and n minus x must be greater or equal to 5. All right. Now here we are not given the value of x. We are just given the percentage. So all you need to do is to find x. You can use your sample size. Our sample size is 1,000, isn't it? This is n equals, because a total of 1,000 American adults were surveyed. So that represents n. And since you have the percentage, you can always find x by multiplying the total with your proportion, with your percentage. So what is 38% of 1,000, right? That's simple arithmetic. So x is 0.38 times 1,000 is 380, which is greater or equal to 0. And if you subtract 380 from 1,000, which is n minus x, the value is also greater than 5. So yes, all assumptions are met. We can proceed and use the Z interval procedure. So now we go on to performing the confidence interval, or we go on to finding the confidence interval. We are asked to use a 95% somewhere here, right? 95% confidence interval. So if our confidence interval is 95%, then the confidence level is 0.95. And from 0.95, you can calculate alpha, which is 1 minus 0.95. So that's how I have 0.05. And in any confidence interval question, you do have to divide your alpha by 2, because, again, always try to draw a diagram for your confidence interval. So this is what's going to happen, or rather what we are looking for is, here's our normal Z curve. So it's a 95% confidence intervals. Let's mark the center point. It's not quite the center point. So let's do this again. So we have the center point here. Let's say we are trying to find the end points of our interval. So with a 95% confidence interval, the end points are going to bind area of 0.95, and our alpha is the unbounded area, which is, all right, 1 minus 0.95. So that's our alpha, the total unbounded area. All right, so we are, so together alpha is 0.05. Each side of the interval is 0.025. That's alpha by 2. Okay, so you can always find the z value corresponding to each endpoint, which would be z of alpha by 2. If it's on the right side, it'll be a positive z value. If it's on the left side, it'll be a negative z value. So what we found here in step 2 is z of alpha by 2, which is 1.96. You can use your table or your calculator. And once we know our z value, z of 0.025, we can just plug in all the values into the variables in our equation. We've given the equation here. If it's not given to you on the test, please go to your formula sheet and find it. This is chapter 12 material. What I strongly recommend is download your formula sheet and familiarize yourself with the formulas for the different chapters, because if you don't, then it'll be rather stressful for you to try to figure out which one is the right formula to use on the test. Okay, so here I've plugged in the values. P hat we found was 0.38, plus minus z of alpha by 2 is 1.96, and p hat is again 0.38, and 1 minus p hat, which is 1 minus 0.38, was 0.62. We found that in step 1, divided by the sample size, which is 1000. All right, so once you do this calculation, and always do the calculation step by step, otherwise you may go wrong with the calculation. If you show the steps but somehow your final answer is wrong, I can give you partial credits. Look at here, I've shown so many steps, and this is only going to help you. All right, and also it'll prevent you from making mistakes. All right, if you somehow you see something doesn't look right, you can always go back to the previous step and do the recalculation and see you can do any corrections if you want to. It's much easier if you work step by step. So here we have our interval of 0.35 to 0.410. Keep in mind what this is. We are talking about proportions here. So 0.35 represents a proportion. It's not difference anymore like in chapter 10. All right, chapter 10 was about difference of means. This one is about proportions. And 0.35 and 0.410 can also be converted to percentage if that's what the question is asking. So you can write your interpretation accordingly. So now that we have our confidence interval figured out, just write your interpretation. Even if the question doesn't ask for it, please write an interpretation. It says we can be 95% confident that the percentage of Americans that drink alcohol at least once a week is between now here we have stated this in percentage. Make sure we have the percentage sign. But if you had written it in proportion, I would still give you the points. But I think, okay, the question says confidence interval for the proportion. So I think it would be a better idea to write your intervals in proportion. So is between 0.35 to 0.41. Okay, so try to answer the question. If the question says what proportion, then write your interpretation in proportion. If it says percentage, write it in percentage. But here I wanted to show that you can convert the interval into percentage as well. All right, so this part of the questions, the next part of the questions is find the margin of error for the estimate of P and express the confidence interval in terms of the sample proportion and the margin of error. So the margin of error is whatever this calculates to, which is 0.030, correct? That's the margin of error. So if you've done the calculation here, you can just state it in the question below. You've already done the calculation, no need to spend time again finding it all over again, all right? Because this is an exam situation and you will, have to finish it on time and solve the questions on time. So help yourself, all right? If you've done the calculation before, just write the answer. All right, so that was the question on margin of error. Now this one, it says obtain a sample size that will ensure a margin of error of most 0.02 for a 95% confidence interval without making a guess for the observed value of P hat. So here you have to find N, and if you recall, and also in the formula sheet, there are two formulas for finding the sample size on proportions. One is without making a guess, and the other is with a guesstimated proportion. This question specifically says without making a guess, so please use the formula which is for without making a guess. And that formula has a constant value for the proportion, that's the P hat value. It has a constant value for the proportion, that's 0.25, because it's actually P hat times 1 minus P hat, really. It uses a P hat value of 0.5. All right, so 0.5 times 0.5 gives us 0.25. Anyway, for when it asks you to find the value of N without making a guess, make sure you use the formula which has a constant value for the P hat times 1 minus P hat. All right, so this is the formula. Plug in the values correctly. What did it say? It says use a 95% confidence interval. So you have to find your Z of alpha by 2, all right, accurately based on this confidence interval given, all right? So if it's 95% confidence interval, alpha would be 0.05, so alpha by 2 would be 0.025. And that's what we found, 1.96. And error, the value of the error is given to us here, all right? Pick the value of the error from this question and not the original question on confidence interval, all right? So when we did the calculation, we came up with an N value of 2,401. If it's not an exact integer value, if it has a decimal value, please round it up to an integer value. All right, so that was the first question on chapter 12, which is just to find an interval, a confidence interval for a proportion. Now here's a question to perform a hypothesis test with proportions. The question is, on Christmas presents, the Arizona Republic conducted a poll of 758 adults who celebrate Christmas. The question asked was, in your family, do you open presents on Christmas Eve or on Christmas Day? Again, this is a yes or no question, or it will have two answers, whether somebody opens their present on Christmas Eve or on Christmas Day. Of those surveyed, 394 said they wait until Christmas Day. So we have to perform at the 5% significance level if the data provide enough evidence to conclude that a majority or more than 50% of Arizona families who celebrate Christmas wait until Christmas Day to open their presents. If the majority of the people in Arizona wait till Christmas Day to open their presents or not. So we'll start with taking the proportions, right? So This time we have to use a formula. Previously, when we were working on the confidence interval question, they had given us the proportion in percentage form, so we didn't have to do the x divided by n to figure out the p hat value. This time we have to. So from the wording of the question, find what n is. N is the total number of adults who were given the survey. That's 758. And X is the number of respondents who said they opened their presents on Christmas Day. All right, so that's 394 here. 394 is X. So P hat, or the proportion of people who open their presents on Christmas Day, is X over N. Plug in the values correctly, and we get a proportion of 0.5197, and a failure proportion therefore would be 0.4803. Subtract your success proportion from 1 to get the failure proportion. We can go ahead and start our hypothesis test now, step by step here. We haven't given you the steps or prompted the steps for you, so you have to remember it by now. You should. Step 1, start with stating the hypothesis. In this case, the null hypothesis will say that the proportion of people who open their presents on Christmas Day is 0.5, right? So if it were more than 50% is what we are trying to conclude, all right? But the null hypothesis will say that it is 0.5. That means it's a 50-50 thing, all right? There's no majority for the people who open their presents on Christmas Day. That's what the null hypothesis will state. An alternate hypothesis will say, no, the proportion is greater than 0.5 if it's a case of majority, all right? Majority will be more than 50%. So P is greater than 0.5. Again, state your hypothesis with population, in terms of population is what I mean, all right? No P hats in stating the hypothesis. Now the tail type, it's a right tail test because we are using the greater than in our alternate hypothesis. Step 2 is about determining the alpha value, significance level. It's 0.05 is what it should be. I'm sorry about that. So I'm going to change that to 0.05. Alpha is 0.05, not 0.5. All right, so step 3 is find the test statistic. Here's the formula to find this test statistic. Now, please note that in the formula, we are using the null proportion. All right, null proportion of 0.5. It's P sub 0, P hat minus P sub 0. And so in the denominator, we also have P sub 0 times 1 minus P sub 0. Whatever the null hypothesis proportion is from here. Pick the value of P from here. So 0.52, which is a rounded up value. Now, again, previously I told you to leave it at the decimal. Please use the decimal up to 3 places. So I still encourage that. But if you have rounded up to 2 places, just because the population proportion is population proportion is 0.5. All right, you can because of that you can round it up to 2 decimal places, but otherwise keep it at 3 decimal places. All right, so here I've plugged in my values for the different variables, and I've come up with a z value of 1.111. all right, so here again keep it at 3 decimal places. Then perform your critical value approach. For all questions on chapter 12, we are using the z distribution. There's no other distribution being used. All right, so sketch your graph, your diagram. It's a right tail test. Which region will be to the right? The alpha value is 0.05, and the corresponding z sub 0 or z sub alpha, z sub 0.05 is 1.645. That's our critical value. So now we bring our test statistic, which is 1.11, and see where that falls. Now it's important for you to show that in the diagram as well. Now this diagram didn't show it, so I'll place it somewhere here. Let's say it's somewhere here, right? 1.11. That's our Z test statistic. Z value 1.111 is less than 1.645. It'll fall in the on the left hand side, to the left, or in the do not reject region of the graph of the diagram. So our conclusion is going to be do not reject null hypothesis. Now for the p-value approach, we bring our z value, our test statistic z value, which is, take out my red pen here, z sub 0 or 1.111. The corresponding p-value is 0.13. All right, now if you're using your table, keep in mind your table will give you the z value to the left. We are interested in the area to the right. So I'm going to quickly draw a figure here for the p-value approach. If I can find some space, let's do it here. All right, so we have our curve, and please draw your or show your where your z test statistic falls on this diagram. Again, there's no reject, do not reject in the p-value approach. Just take your test statistic. If this is the center point, then it'll be somewhere here. Let's say that's where 1.111 is. Again, extend a line up from your test statistic z value on the diagram, and you are looking for the area to the right for your p-value, just because it's a right tail test. So if you're looking up your table, it'll give you the area to the left. All right, so please subtract that area from 1 to get the area to the right. All right, so the p-value is 0.13. All right, the area to the right of 1.11 would be 0.13. This is a one-tail test. You don't have to multiply your p by 2 in this case. Then compare p with alpha. 0.13 is greater than 0.05. Therefore, do not reject the null hypothesis. And that agrees with what we found using the critical value approach. And finally, interpret it. At the 5% significance level, there is not enough evidence to conclude that a majority of Arizona families who celebrate Christmas wait until Christmas Day to open the presents, right? Now, this final question from chapter 12 is on comparing two proportions, all right? So here it says below are the number of successes and the sample sizes for a simple random sample from a population. Answer the questions below for each question. So they've given us the x sub 1 and n sub 1 values, which correspond to population 1, and x sub 2 and n sub 2 values, which correspond to population 2 and then or sample 2. And then they've given us the alpha values. They've told us it's a left tail test, and they've told us to find a confidence interval of 80% towards the end. All right, so now we are comparing two proportions, so we have to find p hat sub 1 and p hat sub 2. Right, recall from our worksheet and from our lecture that that's how we learn to work on questions comparing proportions. So p hat sub 1 would be x sub 1 divided by n sub 1, which is 10 divided by 20. And for p hat sub 2, it would be x sub 2 divided by n sub 2. It's a very simple formula. You should not have to look up a formula sheet to find the formula for proportions. All right, x divided by n. So we got 0.5 for proportion 1 and 0.6 for proportion 2. Their corresponding or respective failure proportions are 1 minus whatever p hat sub 1 is and 1 minus what p hat sub 2 is. And we use the pooled proportion. So this is the formula to find the pooled proportion, and we came up with a value of 0.56, and the corresponding pooled proportion, or the failure pool proportion, would be 1 minus 0.56, which is 0.44. We'll need that when finding our test statistic. Decide whether using the two proportion z-test is appropriate. Of course, other than the it should be a simple random sample and independent samples, we have to make sure that x sub 1 and n sub 1 minus x sub 1, x sub 2 and n sub 2 minus x sub 2, they are all greater or equal to 5. All right, so yes, the procedure is appropriate in this case. We start with our hypothesis test steps. First, state your hypothesis. Null hypothesis, when comparing means or proportions, null hypothesis is always going to say that the two proportions are equal. Again, do not put a hat on the p's when stating your null and alternate hypothesis. So null hypothesis, h sub 0 colon p sub 1 equals p sub 2. H sub a, the alternate hypothesis, is saying that it's less than, p sub 1 is less than p sub 2. Why? How do I know that? Because it tells in the question here it's a left tail test. This is not an application based problem, so you don't have to search in the wording. It's given over here with the other information that perform a left tail test. All right, so that makes things easy, hopefully, for you. Step 2 is to decide on alpha, which is a significance level. And what is the significance level? Alpha is 0.10. All right, so that's what we are using here. Alpha is 0.10. I've drawn a sketch. The reject region will be to the left based on the fact that it's a left tail test. Do not reject region on the right. Our critical value will be negative z of 0.10. Keep that in mind. If the z value is to the left of the center point, it better be a negative z value. Here's the formula. Again, you can look it up in the formula sheet, where it should say that, or rather pick the formula which is to be used for comparing proportions. All right. And we came up with a z value of negative 0.70. That's the test statistic value. And then in step 4, we use the critical value approach, right? And we come up with negative 1.2815. So what is the critical value approach? Or rather, the critical value is negative z of 0.10. So if you look up your table, you should get a value of negative 1.2815. All right, so the test statistic, we bring our test statistic of negative 0.70, and we see that it falls somewhere to the left, or rather to the right of the critical value. All right, if this is the center point, then negative 0.70 will be to the to the right of wherever the critical value is, which is the do not reject region, isn't it? It's the do not reject region. So the decision will be to not reject. All right. So at the 10% significance level, there is not enough evidence to conclude that p sub 1 is less than p sub 2, is how you're going to interpret this. All right. Now, I leave the p-value approach to you for this one, and I'd like you to tell me what the p-value is, if you can. And if you still have questions, just email me. I can send you the critical value, I can send you the p-value for this problem. But because this is a z procedure, you're referring to the z table, you should be able to get the exact p-value from the table, because the table has a complete list of the z distribution. All right, so you should get an exact value for your p-value. Keep in mind, we are looking for the p-value to the left of wherever your z of negative 0.70 falls. We have to find the confidence interval, and it said use the 80% confidence interval. Please check here what interval we are looking for. All right, 80% confidence interval, and again pick the correct formula to find the confidence interval. We are talking about difference here, p hat sub 1 minus p hat sub 2. So we have to subtract the two proportions, sample proportions, and then z of alpha by 2. So we are using a 20, or rather our alpha is going to be 0.20 from a confidence interval of 80%. So alpha by 2 is 0.10, and z of 0.10 is 1.2815 is what we also used to perform the hypothesis test, right? That was our critical value. And make sure again you're plugging in the values correctly. Please calculate the error first, and then you add and subtract it to your point estimate, all right, to this negative 0.10. All right, and we get a value of an interval with endpoints from negative 0.28 to 0.08. What is missing here is the interpretation. Again, that's something I'm leaving to you. It should not be too difficult at this point to come up with an interpretation. Make sure you start with stating your confidence interval at the 80%, or rather, I'm sorry, I need to restate that. All right, so I'm going to erase this. You can say at the 80% confidence interval, which is fine, but I'm used to really writing we can be, or we can be 80% confident. Now, if you're writing at the, that's fine, but make sure you're writing at the 80% confident level, or using the 80% confidence interval, something like that. All right, make sure it makes sense. Otherwise, just say we can be 80% confident, or we are 80% confident that the difference, we are comparing two proportions, so you have to use the word difference, that the difference in proportion, all right, between p sub 1 and p sub 2. Again, the interpretation also has to have population notation. P sub 1 and P sub 2 will be contained in the interval, and then state your interval. Negative 0.28 to 0.08, and also look at the signs, because this is a question on difference. Look at the signs for the endpoints. One is negative, one is positive. That means it contains a 0 for a difference somewhere in between, and that would say that there's no difference between the proportions. And we found the same thing from our hypothesis test. All right, so that agrees with the hypothesis test results, right?